How's your practical yesterday? Is it okay?
Okay.
So you just did the experiment now.
Yes, assistant.
Then after that, you plot the graph and everything. You discuss the graph.
But we just did the experiment.
You just did the experiment. How long you took?
About an hour, 10 minutes.
Then after you collected your data, you just left.
Yes.
Okay. Okay, class. Yeah. So next week I'll be around because I'm take turn. Next week I'll be in charge of the lab. So next experiment I'll be there. So what I plan to do is let everyone come in first. I plan to give a test for you next Thursday. Magnetic field and alternating current. Okay, magnetic field because I think for the first time we can be face to face. So I think I can give you a test. Just 2 questions, short test about half an hour. Okay, magnetic field, the electromagnetism, induction, and AC. The 3 topics. Okay, maybe 2 structured questions or something like that. Okay, so last half an hour after your practical. Okay, because next week also the experiment is easy. I don't think so it's going to drag more than 1 hour 15 minutes. End of the class after we're done with the practical, I think about half an hour I give you a test. On Thursday 2 to 3, do you have any class? Oh,
Yes, chemistry.
Chemistry, okay, yeah. 1 to 2 I go class. So I have to finish by 1. Okay. Just wait for your friends to come in. Okay, everyone is here. Okay, for a few here. Okay. You can see the notes.
Yes.
Yes.
Okay, class. So let's start. So quantum physics. So what we done so far? We done about photon. We done about photoelectric effect. I think on Wednesday we talked about wave particle duality explained by de Broglie. Then we went a little about energy level, atoms, line spectra. Okay. Okay, so we will talk about this in depth today. Okay, energy levels in atom and line spectra. Band theory, we see if we got time, then we can go about band theory also. Okay, so what is photon? A packet of energy of an EM radiation, dependent to frequency. Then we talk about photoelectric effect, the 3 results, which against the wave theory, remember. Then how Einstein explained it. Okay. Then Millikan proof it with that experiment setting, getting a straight line. Then you should know how the graph going to change when the metal plate is changed. Okay, when the metal plate is changed, how the graph going to convert. What gradient represents is depend to what y-axis. Can be stopping potential, can be kinetic energy, can be 1 over lambda. So you have to use y equals to mx plus c with Einstein's formula to compare and get the what is gradient represents. So don't always think the gradient is going to be h over e. It could be other, depend to the y-axis quantity. Okay, then we talk about wave particle duality. So de Broglie said, what is lambda equals? What is de Broglie wavelength means? De Broglie wavelength means a wavelength associated to a particle which possess a momentum of p. De Broglie wavelength, which you could use to wave equation like that. Yeah. So de Broglie state that wave particle unity, wave as a particle nature, particle as a wave nature. Proof is electron diffraction pattern. Okay, now talk about energy levels. So Niels Bohr, I told you the beginning discovery. Rutherford model got one problem. What's the problem? Electron eventually should fall to the nucleus. According to Maxwell idea, Maxwell says that if any charged particle accelerates, it should give out EM radiation. Therefore, the electron should lose energy and eventually should fall to the nucleus. But that never happened. So Rutherford model as a problem in the electron arrangement. So later, Niels Bohr used quantum idea. He said electron as a specific energy levels. So this is what our discussion today. So we go to the PowerPoint. So it's all done. Yeah. So Bohr's postulation. So Niels Bohr in 1913 applies quantum theory to Rutherford atomic structure. He proposed that electron travels in a stationary orbit. That is a fixed orbit for the electron to travel. This led to the calculation of possible energy levels. So you see, this is not in your syllabus, but just introduction. You see, every electron, the circumference of the electron travels will be in a stationary wave. In terms of n lambda. But this you don't need to know. So he discovered there is lots of energy level. The energy level he found out is for hydrogen, energy level of an hydrogen. So you need to understand about this energy level. This energy level, the nucleus is where? The nucleus is at the bottom here. At what do you call? At here. Imagine the nucleus at the bottom here. Nucleus at the bottom here. This the first state. N equals to 1 is we call it ground state. Call it what? It's a ground state of the ground state. The lowest energy level electron can occupy. It's called ground state, the lowest energy level. Okay, the ground state is energy level closest to the nucleus. It's called ground state. What is ground state? Ground state is the lowest energy level can occupied by an electron in an atom. It's called ground state. So electron can stay here. Electron can stay in these energy levels. Electron can't stay in between. Okay, that's the quantum idea. So electron can stay here, randomly. Okay, I tell you the story. When normally this is hydrogen, right? Hydrogen, right? If hydrogen gas at a cold state, very cold, all the hydrogen atom electrons will be found at a ground state. They will be at a ground state, low energy level. Okay, when the hydrogen is heated, when hydrogen is heated, what happened? The electron absorbs energy and the electron will go to the highest state, go up and you gain energy. Okay. So for example, here, these are energy level. This is 13.6. This is 3.39. Okay. The amount of energy required to go up is the differences of this energy. Okay. So 13.6 minus 3.39, negative 13.6 minus negative 3.39. The difference is about 10.21 or something like that. So 10.21. The electron absorbs 10.21 energy, it will go up to this energy level. And so on. If you have more energy, it will go up here. It will go up here. Okay. When hydrogen atom become hot. When the hot hydrogen atom, when leave it cold back, what happened? The excited electron will come down again. It drop down again. Come down. How are you going to drop? Depend. You can drop straight to the bottom. You can drop one after another, like a stairs, like a ball rolling from stairs going down, like one after another steps. Okay. So sometimes you can roll from the second step go to the another lower ground. So go a lot of options lah for it to go down. Okay. So when every time you go to the another energy level, energy will be released. Energy will be released. Energy will be released in terms of photon. In terms of photon. Okay. Let's say electron at N2. Electron is at N2. When it comes out, come to the ground state when it's become cold. So you give out photon. The photon you give out will have an energy of how much? The energy of the differences of this energy level. The difference of this energy level will be the energy of the photon. What is the photon energy formula? Hc over lambda. So in this case, the 10.21 eV will be equals to Hc over lambda, or we can say HF. We can find the frequency of the EM radiation which is comes up. So this is what postulated by Bohr. Electron in each orbit have a definite energy, and they move in that orbit without radiating energy. A free electron, the end will be at infinite, zero potential energy, at infinite. All energy levels are negative. Okay, all energy levels are negative. Why all energy levels are negative? Why energy level here, the ground state is negative 13.6? Why negative? This is same as your Earth gravitational field. You know, Earth gravitational field. Earth gravitational field. You possess a potential, positive potential energy or negative potential energy. You have a negative potential energy, right? The potential energy you possess at the state now is negative potential energy. Why potential energy of the on the Earth surface is negative? Why negative? Because the potential is caused by what? Caused by an attractive force. Okay, any potential gain due to attractive force, that potential energy is negative. So same thing goes here. Here the electron is attracted to the nucleus. So electron experience an attractive force. So the potential energy is due to attractive force. Okay, therefore it should be negative. When go further, the potential become less negative. What is the maximum potential you can gain? Zero. Like Earth, Earth. When you go to the infinite, what is the potential maximum potential energy you can possess? 0 joule, right? Zero. You are completely freed from the gravity. So yes, all energy levels are negative, indicating loss of potential energy as the electron draws nearer to the nucleus. So the negative due to attractive force. The lowest energy level is called ground state. Remember, what is ground state? It's the lowest energy level can be occupied by an electron. For hydrogen, the ground state is found to be 13.6 eV. For hydrogen is 13.6. For helium atom, is it going to be 13.6? It's going to be greater or smaller than hydrogen? Anybody? The ground state of helium going to be greater or smaller than hydrogen? What do you think? Hydrogen got how many proton? Only got one proton, right? Helium got 2 proton. So the attractive force is stronger for helium. So the ground state energy level going to be bigger magnitude or smaller magnitude?
Bigger negative.
But bigger. Because attractive force is stronger. The potential energy going to be bigger magnitude. The magnitude going to be bigger, but highly negative, we can say. Okay. So yes, so the ground state value differ for different atom. But the one so far investigated is hydrogen atom. Hydrogen atom has been investigated. It's 13.6. The N stands for quantum number. This is quantum number 1, quantum number 2, quantum number 3. The number has been introduced from the quantum number. The derivation of this energy level N1, N2 is from the quantum number. Okay. Okay, so electronic transition, the electron transition. Electron can go up, can come down. Okay. When electron goes up, when the gas is heated, the atom is heated, the electron receives energy, the electron will go up. Okay. From cold gas become hot gas, electron will go up. Electron will go to an excited state. It go to the excited, the electron will be excited. excited go up. So when the electron excited state, when it goes up, okay, this called excited state. Photon will be absorbed by the electron. Electron will absorb photon. Means what? Let's say like a photoelectric effect lah. You have a hydrogen gas. You have the hydrogen gas. This H2 here. Okay. The atoms are very cold. They are very cold. So cold means in one atom of hydrogen, the electron is at the ground state. The E is all at the ground state. Okay, they will be at a ground state. Suddenly you shine this hydrogen atom with the light. You shine with the light. Okay. Light, according to quantum, light made of photons. A lot of photons. And a lot of photons exposed to the electron. What the electron do? The electron will take this photon. It absorbs the photon. It take one photon. Then the electron will go to the excited state. Go up. Okay. So let's say electron at the bottom here from 13.6 to go up to the next N2. Let's say energy required. Let's say I put is 10 eV. So the electron will absorb photon which has 10 eV. 10 eV photon will absorb. You absorb the 10 eV, you go up. It stays here. Okay. So the light, let's say the light you shine, let's say is a white light. If it's a white light means got 7 wavelengths, right? Got 7 wavelengths, continuous wavelengths, right? Got 7 wavelengths. Okay. When the light shine here, after exposed to the hydrogen atom, when the light comes out here, okay, the photon which possess 10 eV photon will be missing. Because the 10 eV photon will be absorbed by the electron to go up. So when the light come out here, let's say 10 eV photon happens at the green light. Let's say the green light is the 10 eV photon, let's say. Okay. What happened? The light, which is continuous spectrum here, all rainbow colors is here at the beginning. After it passes the hydrogen, you check the light, the green color will be missing. The green color will be missing. Why the green color missing? Because the green color photon has been absorbed by the electron to go up. Let's say electron to go up from n equals to 1 to n equals to 3. Want to go up from 1 to 3. And you need, let's say, 12 eV. And this light also got 12 eV. And the 12 eV fall under, let's say, under yellow. Under yellow. So yellow photon will be missing. Yellow photon also will be missing. And when the light releases. So depend lah. So the electron, if it has energy to go to the higher state, it absorbs that energy, that photon. Okay. Now let's say to go from 1 to 2, you need 10 eV. To go from 1 to 3, you need 12 eV. Let's say a photon of 10.1 eV is there. 10.1 eV is there. You just shine with a monochromatic light, not color light anymore. You just shine with the one monochromatic light consists of photon energy of 10.1 eV. Do the electron will absorb? According to quantum, they say it won't take that 10.1 eV. Electron won't take the 10.1 eV. According to quantum, they said electron only take the energy just required to jump to that next state. The next state, the energy required 10 eV means only take the photon with 10 eV. 10.1 it won't take. 10.2 it won't take. It only take 10 eV to go to 2. It only take 12 eV to go to 3. Other photons different from 12 and 10, it won't absorb. Only specific photon it take to jump to up. Okay. So yeah, that's the first movement. Is there any part you don't understand here? It's a new idea. So electron will jump up, electron will go up. When a source of energy is exposed to the electron take the specific photon to go up. This is called from de-excited state, it go to the excited state. It's called excited state. Okay. After the light is stopped, the source of energy stopped, what happened? The electron in excited state, right, won't stay there for a long time. They eventually will fall down. When they fall down, they will release this photon. That called this diagram, this right hand side, de-excitation happen. Electron will come down. How the electron will come down depend. Many varieties like the electron will come down from top to down. Okay, the electron can come down from here to here. So get many varieties. Okay, let me show what varieties it can come down. Okay, let me draw one. Let's say the atom got 4 energy level. Okay, n equals to 1, n equals 2, n equals 3, n equals to 4. Okay, let's say the electron is at the excited state. Okay, got few let's say that in hydrogen atom got millions of atoms, millions of electrons is excited state. So how they can come down is first from the top level here, like as I said, it's like you roll a ball from a stairs. You roll a ball from a steps. This is like the 4 energy level. This is the ground state 1. This is 2. This is 3. This is 4. We don't know the ball. The ball is like the electron. Okay, analog. The ball, if it's here, give out energy. Okay, sometimes hit here and hit here, so you give out photons. So if you jump here, the next level, 3 photons will come out. Got 3 photons. 3 photons, the 3 different energy levels will come out. Sometimes the ball can straight come to the ground. Okay, only release what photon? 1 photon. Sometimes the electron, the ball can hit the second one, then hit down 2 photons. So got variety of de-excitation. But in exam you have to show all. So easiest way to do that is from the top. From the top you go down once. This is one type of photon will come out. From here you can go to the second level. From top you can go to the lowest level. So 3 type of photon will come out. Okay. This is the first photon, E1. The energy is actually, this is N1. This is E1 is actually what? Transition from 4 to 2, right? So energy of 4 minus energy of 3, the differences in energy is equals to the photon energy, photon which is released, HF. So E1, the energy, the photon released by the E1 from 4 to 3rd transition, the HF is equals to what? The energy differences of the energy level. Let's say the top is 15 EV, negative 15 EV, sorry, put a round figure. Up is negative 10 EV, down let's say negative 12 EV. Okay, this is I put, let's say maybe negative increasing, negative 20 EV. This let's say negative 40 EV. Okay, so transit from 4 to 3, the photon energy release, the photon will have possess how much of energy? Negative 10 minus 12, so it's going to be 2 EV. The photon released by 4 to 3 is 2 EV of photon. Okay, the photon has energy of 2 EV. What is the frequency of this photon will be? We can calculate 2 EV equals to HF. But 2 EV, of course, if you use HF, 2 EV change to joule and change to joule times 1.6 times 10 power negative 19. You can find the frequency. Okay. So the photon, if the energy difference is big, the frequency of the photon going to be big. Whichever. Okay. So this is the 3 transition from the highest level. Okay. Then the electron at the second level here, one drop at the second level, can go down here 3 to 2, can go down 3 to 1. Then electron at the second level might go straight to down. How many type of photon can be emitted if you have 4 energy level? 1, 2, 3, 4, 5, 6. 6 different types of photon possible to be released. Okay, for 4 energy levels, 6 different types of photon can be released. Okay, so in exam they will ask, out of this 1, 2, 3, 4, 5, 6, 6 photons, which photon has the greatest energy? Which photon has the greatest energy? Anybody?
The one that drops the most.
Most. So which one? In this case,
The
3, right? 3, yeah. 3 has the greatest what? Greatest energy. So photon 3 has the greatest energy. Therefore, photon 3 has the greatest frequency, right? Photon 3 has the greatest frequency. Another word, vice versa, the photon will have a lowest wavelength. Okay, lowest wavelength. So 3 is going to be the photon with greatest energy, right? Okay, this one. Out of 1 to 6, which is going to have the smallest energy? Smallest energy, anyone? Number 1. Number 1 will be the smallest energy. The photon of number 1. Number 1 is the smallest energy. Why number 1 is the smallest energy? Because the energy level is quite close. Okay, I tell you, from the quantum development, the ground state and the first state is the furthest, When you go up, the energy level is found to be get closer and closer. This is the quantum development. Closer and closer. The energy level seems getting closer and closer. So the top transition, the energy release is very, very small. Okay. So when this transition happen, for a hot gas, when the atoms, electrons are in excited state, and leave it for a while, the electron will be de-excited and releases photon. Okay. In exam, they will ask you to draw this line. They will ask you how many photon will be released. They will ask you what is the photon with the greatest frequency. Greatest frequency, the one with the greatest energy. They can ask which is the smallest frequency. They can ask what is the highest wavelength and so on. Okay. So yes, so this is what happening. So if you have 3 energy levels, you have only 3 energy, n equals to 1, n equals 2, n equals 3. When electron is at an excited state, tell me how many types of wavelength will be produced? Draw the de-excitation. When it de-excited, how many types of photon will be produced?
3.
3. From 3 it dropped to 2, got 1. Then 3 it dropped to 1, another one. Then from 2 it dropped to 1. The other one. 3. Which photon has the greatest energy?
2.
2. Photon 2 has the greatest energy. So greatest frequency and the smallest wavelength. So remember, number 2 has the greatest energy, greatest frequency, smallest wavelength. And number 1 is the other way around. Smallest energy, smallest frequency, greatest wavelength. Okay. Okay. So yeah. Let's go back to the point. Yes. So electron will go up and will come down. Electron, when it goes up, we call excitation. Electron excited to the higher energy level. When this happens, when the electron receives energy from an external source, maybe in terms of heat, maybe in terms of light, radiation, maybe in terms of collision. Collision means what? Electron was bombarded to this atom. The electron when come and go get into the atom, it collide with the inner shell electron. It transfers some energy to the electron, the inner shell. The electron will excite it. So there are three sources of energy the electron can get. One from the light, EM radiation. One can be a incoming electron, high-speed electron come and he collide with the atom here, with the electron inside here, and electron will be excited by absorbing energy. And third may be heat. But your syllabus, the light and the incoming electron. Okay. Okay, now, yeah. So now you are sitting, you are in a room, okay, what you are just viewing the laptop, okay. Now, when your room, let's say in the dark, when the room is in the dark, you shut down the light, okay, it's dark, you know, the atoms on the stones, atoms around the, all matters full of atoms. So when it's dark, all the electrons in the atom will go down to the ground state, according to quantum idea. They will, all electron will be at a ground state, there will be low energy. When you switch on the light of your room, the atoms surrounding will absorb energy from the light, the one it needed. The electron will go to the excited state. Go to the excited. The first thing will happen on the left one. Okay. Then after a short while, after you shut down the room light again, it become cold. The electron will start to lose energy. Will go down. De-excitation happen. You give out radiation. The radiation give out is unique to the energy differences of its moving. Different type of radiation will happen. That means each and every day, you are sitting there in your room, the electron in the atom is consistently excited and de-excited, depend to the energy level. That's a quantum idea. Okay. One example, a clear example of this is the fluorescent. You know, your watch at each numbering, you have the fluorescent material, right? The number. Okay. So let's say you go to the bright room. Suddenly, when you go to the dark room, what happened? You can see the fluorescent materials are glowing. Why it's glowing? Okay. Why it's glowing? Because this de-excitation and excitation happens. Fluorescent has a unique energy level where when the electron goes up, when you go to expose to the bright light, the electron goes up. Then when it de-excited, there is one I don't know which energy level. There is one energy level. The differences, the wavelength fall under visible range. That's why it give out light. Okay, fluorescent give out light. It glows because the type of radiation it emits out, it's a visible. The wavelength is under visible range. So that's why you see visible light comes out from the fluorescent. Okay, but now your laptop got a lot of atoms, right? They are stone as atoms. That one also, when you shut down the light, it never glows. It never glows because of what? Is that means it never glows means the electron never go down? Electron still de-excited, but the frequency it emits out, the wavelength it emits out, doesn't fall in visible range. That's why you can't see the radiations. Okay, fluorescent, the energy level looks like in visible range. That's why it's glowing. Okay, any questions, guys, so far? My explanations, any part you don't understand? Okay, so I hope you understand. This is the idea of energy levels by Neil Bohr. Electron only have specific energy levels. Electron only allowed to go up, come down at that specific energy levels. If you want the electron to go up, the electron must absorb energy from surrounding in form of other EM radiation or incoming electron. But the electron which is going up, not going to stay at the excited state always. When it become cold, it come down, releases photon. How many photon are you going to release? Depend to the energy level. Okay, just now I'll show you 3 and 4. How many type of wavelength will come out? So you have to know how to draw it. Okay. Now, so this what story I told you just now. Electronic transition. The electronic transition from energy level to another required absorption of emission photon. Vertical arrows drawn between the energy levels. Electron goes up, it absorbs energy. When it comes down, it emits photon. The energy of that photon is equals to the high energy to the low energy differences. That's the photon. The energy difference between adjacent states are not equal. N1 to N2 is not same as N2 to N3. N2 to N3 is smaller energy. more bigger number of n, the energy differences is even smaller. Okay. Okay, so let's try one question. This is one example. The idea I told you. Okay, I give you 2 minutes. Read the question. Try to get some idea. How are you going to go about it? Give you 2 minutes. Okay, so you got some idea how to do. Okay, so our question is all about hydrogen atom, because so far the discovery is about hydrogen atom for energy levels. Okay, so this is the energy levels for hydrogen. What is the ionization energy of the hydrogen atom? Okay, what is meant by ionization energy? The energy required for the electron to completely release from the atom attraction. Ionization energy, the electron is completely released from the atom. The ground state energy, the ground state energy is the ionization energy. Okay, so if the electron get energy of 13.6, the electron completely will be released from the atom. The atom become ionized. Ground state energy. Okay, so ionization energy means the ground state energy, 13.6 eV. Okay, B, what is the minimum frequency of the photon that is required to cause an electron in the ground state of the hydrogen atom to be ionized? So, what type of light you must what type of light, what frequency light, or what frequency of EM radiation you need to apply? What frequency to ionize the electron? So the energy of EM radiation will be in form of photon. The photon energy must be equal to 13.6 eV. The photon comes in, if HF equals 13.6, that's the frequency we're looking for. So we can find the frequency. HF equals to 13.6. But EV change to joule. Don't put in EV and equate with HF. I have to be in joule. 30.6 times 1.6 times 10⁻19, you get frequency. That's B. Okay. So see the B. The minimum frequency, HF equals to the energy. So 13.6 must convert to joule. Okay. So 3.3 times 10 power of 15 hertz of EM radiation needed. Exactly. Okay, see what would be likely to happen to photon of energy 12.75 to 15 eV. Okay, C is a good question. You have a light. Okay, let me clear this. You have a light source was exposed. The light got only two type of photon. First type of photon is 12.75 eV, another one is 15 eV. When this photon exposed to this electron at a ground state, do the electron will take both, or which one it will absorb? Or is it not going to absorb both? How to check? Check is it equal to the energy differences? Because electron very fussy, you only take the energy required just nice to jump. So do you going to absorb 12.75? 12.75? 12.75, if it absorb, we can go to which energy level? I think 13.6 minus 0.85. Right. 13.6 minus 0.85. I think it's 12.75 from here to here. 12.75. V, right? So 12.75 eV photon, the electron will absorb. Electron will absorb, straight go to this energy level. Electron stays here at energy level of 4. 12.75 will be absorbed. 15 eV won't absorb. 15 eV, it just passes. Okay, because only need 13.6. So the photon disappears as energy 12.75 is absorbed by the electron at E1 and is subsequently transited to E4. Photons of energy 15 eV, the photon will pass through the atom without being absorbed. The photon of energy 15 eV does not fit into any available energy interval. So if you have a green light, let's say 12.75 is the green light and 15 is a blue light. Green light, blue light, both you shine at this atom. The one later re-emitted out will be the blue light. Only blue light will be re-emitted, will be leaving the atom. What happened to the green light? Green light will be absorbed by the electron. But when the electron go to the absorb the green light, let's say green light is 12.75 eV, let's say. So green will be absorbed by the electron go to the 4th level. But after a short while, maybe a few seconds or few minutes later, the electron will drop down. When it drop down, let's say it drop down to 3 levels, 3 levels and drop down. This 12.75 photon will turn to become 3 different photons, 3 smaller photons. 3 different wavelengths will be produced. Or if the electron straight jump to the ground state, I give out green light. You can give out green light. This transition is very random. We cannot tell. A lot of possibility of wavelength will come up. Okay. So yes, this is for C. 12.75 will be absorbed, but 15 eV won't be absorbed because it's not in any energy differences. Okay, any questions from here? Okay, now look at D. The electron, a bombarding electron of energy 5 eV and 11 eV collide with hydrogen gas in a ground state. So now 2 electron from outside electron come and collide with the inner shell electron. Okay, 1 electron got 5 eV, another electron got 11 eV. Okay, what will happen? Okay, now the electron here is waiting with 13.6. You want any energy to go up. Okay, 5 eV first. Is the electron going to take the 5 eV? Pointless one. Go to the immediate energy level itself, you need more than 5 eV. You need about 10.2, right? You need about 10.2 eV. So 5 eV is for this electron is useless. So what happened? The electron with 5 eV energy will come out. That electron will come out with 5 eV. It won't lose any energy because the inner shell electron won't absorb the energy. Pointless to absorb the energy because it can't go anywhere. Okay. Now 11 eV. Is it going to absorb 11 eV? The energy of 11 eV. When electron comes in with the kinetic energy of 11 eV, this inner shell electron to go to the next level, you need 10.2 eV. But the incoming electron got 11 eV. So what the electron do? Electron can retrieve the amount of energy likes from this electron. Photon cannot. Photon, either you take the entire photon or you don't take the photon. That's photon. But kinetic energy of the electron the electron in the inner shell can take whatever the fraction of that energy. Okay, it can take the fraction of that energy to go up. Okay, so because this incoming electron got 11 eV, so this electron need how much? You need 10.2 eV to go to the next level, right? So it absorbs the 10.2 eV. So this electron will be excited. So the electron which is incoming with 11 eV will come out with how much of energy? Anybody? Because 10.2 eV already absorbed by the ground state electron to go up. So 11 minus 10.2, the incoming electron will be released with energy of the remaining 0.8 eV. The electron will come out with 0.8 eV. So that's the difference between photon and kinetic energy of electron. Photon, either you take all or you don't take the photon. Kinetic energy of electron, you take as much as you require. You need 10.2, but the incoming electron got 11. You take the 10.2, the electron will jump up. Okay, so that's the difference between C and D, photon and kinetic energy of electron. Incoming kinetic energy, you can take any fraction of energy from that incoming electron to go up. Photon, you can't. Either you take entire or no. Okay, any questions from here?
Sir?
Yeah.
Every time an electron releases a photon, drops energy level, does it necessarily release one photon every time it jumps? Every time it drops?
But is it going to drop from the level 4 to level 0 or level 1? You mean? It's a level 4 to level 1.
Yeah.
You say, is it going to be only one photon comes out?
Yeah.
Depend. Let's say you have the first electron straight come down. I give out one photon. The second electron might fall down like this.
Yeah.
So it gives four photons.
So it can, like, for example, it drops by one energy level, for example, 4 to 3, it can't give out 2 photons, but
only one photon.
Okay.
Only one photon. Okay, so that's the idea. C, D. Now E. If a hydrogen atom is in the energy level of 3, let me clear this. If the hydrogen atom is in the energy level of 3, show all possible transition that the electron can undergo in the diagram in the find of corresponding frequency photon that are emitted absorbed during the transition. Get the electron can undergo on the diagram and find the corresponding frequency of the photon that are emitted, or they want emission. We go for emission spectrum. The electron is at 3. What are the photon will be emitted? Possibility. This electron will go down here or go down straight, right? Go down straight down to E3 to E5, or from E4, E2, you can go to E1. So E3 to E2, E3 to E1, or E2 to E1. Three types of photon can be released. 1, 2, 3. Okay, that's the answer. Yeah, 3 types of photon will be released. Okay, so how much these photon energies when they released? So the energy differences here 3 to 1 energy, 3 to drop to 1. 3 to 1 is the greatest energy. Will lead to get you the greatest frequency, 2.9 times 10 power 15, and so on. 3 different type of frequency will be released. The 3 to 1 going to have the greatest frequency or the shortest wavelength. Okay, any questions from here? Okay, we're almost done with the line spectra. Okay, so Niels Bohr tells this story from theoretical, but is it this happening? You need to have a proof. The proof is line spectra. Line spectra is proof for Niels Bohr's idea. And after line spectra was revealed, it proves Niels Bohr is correct and got a Nobel Prize for that. Okay. What is line spectra? Line spectra got two types, got emission spectrum, absorption spectrum. What is emission spectrum, absorption spectrum? When the electron go to the excited state, called absorption spectrum. Means what? The first left one is absorption spectrum. The electron absorbs photon, it go to the excited state. Absorb, because the absorbed photon called absorption spectrum. The right hand side one, the electron go down, emit photon. You go to the de-excited state and emit photon, called emission spectrum. This called left is absorption spectrum, right is emission spectrum. Okay, so this experiment setup, this is the absorption results lah. Okay, it's a filament. It's a the photographic film. They see some lights on it. So to understand this further, we go to the setup. This is a setup for emission spectrum. Emission spectrum means what? Electron goes down or goes up? Emission spectrum. Emit photon. Emit photon means electron goes down, right? From high state to low state. So here, the electron originally must be in a high state. So the gas they use, the hydrogen gas they use is a heated gas. They use a heated gas. So that the electron is in a high energy level. So the electron in this gas is in high energy level. So electron is said to be in high energy levels. We leave it for a while. It should be done in a dark room. Okay, no light from outside. So when the electrons slowly go down, okay, it will give out some photons, it give out frequencies with some specific wavelength. That wavelength light will be focused to a prism, and the prism will shine to a photographic plate. So photographic plate will trace a missing photon here, missing light. Okay, some light has been emitted by this source. That's called emission spectrum. So this is the emission spectrum, the first appearance. Some light has been produced by the heated gas. This light is actually characteristic of the energy level. The characteristic. If we had a three energy level, three different type, only three lines should form there. Okay, you got many because electron got many energy levels. Okay, so they found this emission spectrum. What is emission spectrum? Discontinuous colored line superimposed with the dark background. It's a dark background. It's a dark room one. No light on the photographic plate. Only the light emitted from the gas was captured. Okay, that's emission spectrum. Okay, then if Niels Bohr is correct, means now they did repeat the experiment with absorption spectrum. Absorption spectrum, they use the same. They use the same gas, but now the gas is a cold gas because they want the electron to be in the ground state. They expose this gas now with a light source, with a light source with all the visible lights from entire visible lights from this light source. So got a lot of photons. So if Niels Bohr correct, the electron only can take the specific photons absorbs to go for an excited state. So the wavelength, which all the wavelengths, when passes the cold gas, what happened? Some photon will be absorbed by the electron gas, and the photon you're going to absorb are the same as the photon releases here, right? Because the energy release is actually the characteristics of the energy differences, the energy level. When go down, it releases 2 eV, means when absorb also you need to absorb 2 eV to go up. So the same photon should be disappear. So when they do the experiment, they found in the emission spectrum, the light which is appeared, the same line has been disappeared in the absorption spectrum. It means electron as energy levels is proven. Electron as specific energy level. That concept has been proven. What is the proof? Line spectrum. You've got two types of line spectrum: emission spectrum, absorption spectrum. In exam, they will ask how the emission spectrum, absorption spectrum looks like. So you have to explain. Emission spectrum, discontinuous color lines with a dark background. Absorption spectrum, discontinuous dark line with a colored background, continuous spectrum. Because originally we shine light here, the second one, absorption, some light is missing. That's why. The light which appeared in emission is the one disappeared in the absorption. So once this is the proof for Niels Bohr's idea. So Niels Bohr got a Nobel Prize. So they agree that electron has energy level, and the quantum idea become even more dominant. Become more people start to believe his idea. Cannot neglect, because it solves a very big problem in a energy, what do you call, atomic structure. So quantum physics solves the problem of electron energy levels. Okay, any questions? No questions, Okay, guys, I think time's up. So this is what we learned today. We go through that. Next class, we go to band theory. Okay. So what you learned today? You learn about the energy levels, the transition, absorption, and emission, the contribution of Niels Bohr. Any questions? Okay, guys. So I see you on Monday. Monday we'll be doing practical. I will be doing practical. We're going to go for the design experiment. Okay. So I'll send you a video for you to view. So Monday we discuss practical for 1 hour. Okay. Any questions? Before I attended. Yes, see you then. Thanks.